Good morning everyone, and today we will see how to obtain this structure. It's a very simple tutorial, but it required to have Parakeet installed, so you can use the tiling option here. In particular, we use the uniform tiling C, and it is a simple morphing tutorial. So we are going to morph a partner. Here is our partner that obtained with this hyperbolic tiling A, and we morph this partner inside this surface. It's very important how you build the surface. In this case, I built this surface doing a 180 rotation, and the rotation axis is this line. It's very important you build the surface in this way, because if you build the surface in other way, maybe you don't have the same UV mapping distribution of the surface. So basically I built this pattern, and moving the geometry of this pattern, we can move the geometry of the overall surface. So for the moment I simply delay these lines so we can see the geometry, and so we can see that moving this slider I move directly the configuration of the structure. Perfect. So we can go forward and see how to obtain this geometry, this morphing. As I said, we built the pattern. So this is the section of the 2D tiling. I assigned some values to this parameter, but you can play with them. The main part is basically this one, the morphing. To have the morphing, we need a geometry, that is our pattern. We need a reference box, that is a bounding box that we create around the partner. So we have the partner, we create a rectangle, and then we give an highness to this rectangle with an extrude, because this kind of surface morph, that is the basic surface morph of Grasshopper, required a volume box to be a reference box. So we need some to give height to the basic rectangle, and then surface, and we need the surface in which we want to project the pattern. So I gave this the surface we built in we built directly in Rhino. So this is our target surface. So basically we have a pattern, a reference box, and a target box, and then we join it together, and we give 1 1 1 to the U, V, and W parameter here. Okay, now what we have is this, basically this composition of line. Let me enable the preview. So what we have at the moment is a combination of closed curve that I explode, and then I need to do this sequence of component in order to eliminate duplicate cores. So for each course, first I explode, so I have only segment or arc of curve. Then I evaluate the position of the midpoint of each one of these curve. Then I evaluate the I eliminate the duplicate point. Then I evaluate which one of the point of this collection is next to the called point. So you can see we have 1028 points. When I eliminate the duplicates, we have 692 points, and then we want to evaluate which one of the point of the first list is closest to one of the second list, because we use this because we can retrieve the index of the points we are looking for in the first list. With this index we can use list item to take all the segment without duplicate. And this is the right way to insert the curve inside the multipipe. Remember to flatten them, because multipipe doesn't require hierarchy. And then the last part of the tutorial is to assign some values to the parameter of the multipipe. So we can assign node size and offset, strut size, segment, kick, angle. You can also play with them, looking directly to the results. And the very last part of this tutorial is okay, we have a structure, but we have to fill the structure with, for example, glass, if it will become like a roof. So we can use the same surface morph to project not only the curve, like we have done before, not only the pattern, but we can project also the surface. So we have a closed planar curve here. We can close them basically with a boundary. So what I'm doing is, if I go back to the pattern, I'm going to create a surface for each one of these closed polyline, and then I use this geometry as a geometry input of another surface morph. So here I'm projecting curves, here I'm projecting surface onto the main surface. So we keep the same parameter of before, so we can also copy and paste this surface morph, and instead of put the pattern directly into geometry, this time we use the boundary, the surface inside the, we put the surface in as input into the geometry input of surface morph, and so we have the projection of the surface this time. And so we obtain these parts, basically these parts. To these parts I assign a material that is glass material, so it's transparent, basically transparent. And so these are the very simple passage to obtain this kind of structure. But I repeat, it's very important how you build the surface, the target surface. So it's very important in this case that you create this surface making a revolution. And please, if you like the tutorial, that is very simple in this case, you can subscribe to the channel, and I wish you to have a good day and good job. Bye bye.